This video is about cumulative frequency graph. The distribution of the weight of potatoes is shown by the cumulative frequency curve. How many potatoes are in this data? When you see this cumulative frequency curve, the first step is to figure out the box scale from here to here. It's 50. 100 minus 50 is 50. Then divided by the box, small box, 1, 2, 3, 4, 5 equals 10. Cumulative frequency curve start at 20. Let's go to the y-axis. 100 minus 0 divided by, count the box, 1, 2, 3, 4, 5, 5 equals 20. So each small box is 20 potatoes. We want to figure out how many potatoes are in this data. Let's go to the ending points of this curve. Going down, the maximum weight of the potato is 400 grams. Horizontal, this is 760. Each box is 20, so 760. In other words, there are 760 potatoes in this data set, not 800. Find the median weight. First of all, we need to figure out ordinal numbers. Ordinal numbers means the first, second, third, and so on. Find the median weight. You have to find the ordinal numbers. 50% times 7/60 is the ordinal number, equals 3/80 on y-axis. Find 380. Each is 20, so this is 380. Then you need to draw this horizontal line. Then going down. You could say this is 190. So the mean weight is 190 grams. So the median weight is 190 grams. Find the lower quartile, which is Q1. We are looking for Q1. Still, you need to figure out ordinal number. 25% times n. This is the ordinal number for first quartile, which is 1/90. So find the 190 on y-axis. This is 180. In the middle, then you're going down. Just estimate. You could use 142, 143, and so on. As long as your answer is between 140 to 150, we count that correct answer. So 142 gram is the first quartile. For upper quartile, Q3, the ordinal number is 75% times nth. N is 760 equals 5/70. So go to 5/70. This is 580. This is 560. So 5/570 is in the middle. As long your answer is between 240 to 250, we count that correct. 243. Q3 equals 243 grams. Let's go to B. Find the number of potatoes in the sample with a weight of less than 200 grams. I will use X stand for this weight. Let's form this compound inequality. Less than 200 grams. It has to be greater than 20, because the minimum weight of the potato is 20. The number of potatoes, we will use cumulative frequency. So weight is 20, the cumulative frequency is 0. 200, find the corresponding cumulative frequency. 200 is here, go up. Then this is intersection. Then draw this horizontal line. We got this is 420. The number of potatoes, we will use 420 minus 0 equals 420. So there are 420 potatoes in the sample with a weight of less than 200 grams. Look at the C. Find the number of potatoes in the sample with a weight of more than 350 grams. Compound inequality. More than 350 grams. Less than maximum weight is 400. So write down this composite inequality. Then figure out the corresponding cumulative frequency. 400, the corresponding cumulative frequency is 760. 350, this is 350. Then horizontal value. It's here, 740. Then 760 minus 740 is the number of potatoes whose weight is more than 350 grams. Look at the D. Given that 40% of potatoes weigh less than kilograms, find the K. Let's form this compound inequality. Less than kilogram, it has to be greater than 20. So look at the CF. CF, when weight is 20, CF is 0. 40% of the potato, 40% times 760 equals 304 potatoes. So cumulative frequency will be 304 plus 0. That is 304. Go to y-axis, find the 304. This is 300. 04, it's very close to this 300. Just estimate. This is 171. So K equals 171. Have the E, given that 10% of potatoes weigh more than G grams, find G. Let's form this compound inequality. More than G, less than 400. Corresponding cumulative frequency, 400 is 760. So 10% times 760 equals 76. We need to figure out this cumulative frequency. 760 minus 76 equals 684. Now let's go to 684. This is 680. Very close to this 680. Answer should be between 290 to 300. I will use 291. So this G equals 291 grams. Let's go to F. The weight of the smallest potato in the sample is 20 grams, and the weight of the largest is 400 grams. Use the scale shown below to draw a box and a whisker diagram showing the distribution of the weights of the potatoes. You may assume there are no outliers. Minimum is 20, maximum is 400. This is 25. So we estimate 20 is here. 400 is here. We draw a line. 190 is the median weight. So get over here, estimate. Q1 is 142. In the middle, it's 125. So we just estimate this is 142. 243 is the third quartile. In the middle, it's 225. So just estimate over here. Then we need to draw a box. Erase this inside this line.
That's all.